Okay, so what do we got today? Talking about an earlier Evan, just a line segment. A line segment. No, we'll get to that one later. Third try.
Is it just
Good. So I would, so give me your definition. Well, all lines are straight. When a line by definition goes on forever. So if I asked Evan what a line segment was, and he's given me all kinds of great answers, but I'm being a jerk and nitpicking that. Now the reason I'm doing that is because we're going to come up with a definition that he's writing, and that definition has to be 100% accurate. So I'm trying to get him to the point where we need to be. So solid information so far. Taylor, you want to jump in on this?
It's a line, but it has like 2 points and like no arrows. Like it doesn't go on forever.
So is it a line then?
No. It's a segment of a line.
It's a line segment.
Well, but you can't use the word you're trying to define to define.
Part of
What is a dog? A dog is a dog. You see what I'm saying? What's a line segment? A line segment's a line segment. Allie, what do you got?
A line segment is a part of a line. It's like
Part of a line, not bad.
But it says line.
oh
That's
my
okay.
goodness.
Oh, I thought you weren't supposed to say the word.
You're supposed
Well,
to
you
say
can't
Line
say
segment.
line segment.
Everyone knows that.
So you're almost there, but we need one little last chunk of information. If I take a line and I erase one of the arrowheads, is that part of a line?
No, it's a
Oh,
round.
okay.
Okay, so then how do you distinguish array from a line segment?
Ooh, right here. Up top.
Line segment has
I
here.
guess I'll be calling on Jack now. Excuse me 1 second. Yes, Jack?
Array has an ending point on one side.
Wait, we're not talking about array, we're
Oh,
talking about a
segment?
line segment.
Segment, okay, it stops. Okay, it starts somewhere, then it stops, and then it's only that one spot.
Okay, what's the fancy math term for starts and stops?
Point, line, point.
Let me ask my question again. Listen, what's the fancy math word for starts and stops?
Segment. Bruh! Wait.
Beginning and end.
Oh, wait! No, beginning and end.
That's
Bruh! Wait, what? Wait!
It's one word.
It is? You know it?
He said it's one word.
Race.
Nice.
You're bringing race into this discussion?
No.
Wow, that got real quick.
No, the start and the end.
Yeah, he got it.
Finite!
Oh,
Finite.
Thank
Whoa,
you.
I said it.
I thought
I know that.
Okay, so a couple things that we need then for the line segment. Number one, it is part of a line. Good. Number two, it's finite. Is that enough?
No.
Part of a line that's finite to define that.
Yes.
So before we have that discussion, what I'd like you to do is draw a picture of a line segment in your notes so I can come around and see it.
Oh, it's just a line, just a line. With points, points at the end, points at the end. Has to be points. You sure?
Okay, good. So everybody's in agreement of what that looks like. So since you all have the same picture in your notes, then we all agree what it would look like, and I ask the question again, are those two combined parts, being part of a line and being finite, sufficient enough to use as a definition for that thing?
No.
No? Why not, Jack?
You gotta have points on each end.
Doesn't it have points on each end?
Yeah, but not the finite. The finite is just a line. Oh, wait. Oh, never mind.
So some of you drew your line segments with big honking dots on both ends. And some of you just drew a regular line segment without big honking dots on the end. Which one is more corrector, or are they both correct? Is there a point on the end of that line segment whether you draw it or not?
Yes.
Yes, so do we need that?
Yes.
No.
Yes.
No, represent, represent,
If you
represent.
don't need a dot, then you don't need it in the definition.
Say again?
If you don't need a dot at the end, then you don't need it in the definition.
Okay, so Lily, does that mean then that a part of a line that's finite good enough for a definition?
Okay, fine, this is set.
Lily?
Yes.
Yes. Do you all agree?
See. Yes.
Good, there's your definition.
Well, I don't agree.
What they say?
A segment that is finite.
Wait, how do you spell segment on the line?
Finite, F-I-N-I-T-E. It's infinite without the in. See, opposite of it.
I'm just gonna block out the haters.
And I'm just gonna.
You're so extra.
Because you're talking the whole time, you're talking over me, and when I get instructions, you're asking questions about things I just addressed.
How do you do dark
Very
mode?
good.
Dark mode.
You just do dark background. It's nighttime.
2 ways to name your segment.
No, wait.
Now, when we had a line yesterday, you could pick any 2 points on that line and name it that way. So on the homework, when you had the line CD with the points X and Y on it, you could pick any combination of those 2 points to name the line. Segments, you don't have that flexibility, you have to use the endpoints. So if the endpoints are A and B, that's segment AB, or you could do BA, it doesn't matter which end you start with. So it looks something like, where's my segment? There it is. Got to use the endpoints. Even if there are, well, there are other points on that line segment, but when you name it, you've got to use the endpoints. Okay, so on that segment that you drew in your notes, please label it XY, and then put a point Q between X and Y. Vic, where on your segment did you put Q?
Well, I fixed Q in the middle of like my line.
Okay.
Because like my line is kind of smallish, so like I didn't want to.
Smack dab in the middle. How many people put Q smack dab in the middle? Raise your hand. Who did not? It doesn't matter? Why not? So I could put it.
It just says in between, not in the middle.
Ooh.
It has to be in between.
So it could be closer to X or closer to Y.
Yeah.
Doesn't matter where it goes. No, as long as it's between. Did anybody put Q off of the line segment? Okay, because it doesn't say it has to be on XY, but you all chose to put it on XY?
Oh, it says between.
It says between, it doesn't say on the line segment. Okay, but you all did it correctly. So we're going to talk about the difference between, no pun intended, between a point being between X and Y or being in the middle between X and Y. There's a big difference. Okay. So how many points are in the middle between X and Y?
No. As many as it.
Just one. Okay, if you pick up that segment and fold it in half, there's only 1 point in the middle. How many points are between X and Y? An infinite, right.
But how's it infinite?
Wait, can you repeat that?
Yes. Let's suppose that's my segment labeled XY, I have it labeled AB, and I put Q on there. Okay. The question is, how many points would be smack dab in the middle between A and B? There'd be only one. It would be right there. Okay. Which we'll get to in a second. My, again, this is a bad pun. The point I'm trying to make is that for betweenness, you can put it wherever you'd like. So I could take this point and put it over here, and that's still going to be between A and B. Okay? So let's call it Q. Is that clear? Question?
You said it was infinite. How is it infinite?
Because I can take any point on that segment. How many points on that segment?
I don't know. Like, because it starts and it stops.
Correct. Anybody else? How many points on that segment? No. There's infinite number of points.
I just don't get how it's infinite.
Well, that line segment, Evan, you want to answer the question, or you have another question? You want to answer it? Go ahead.
The points can just be getting smaller and smaller numbers.
Right. So remember from yesterday, those points have no size. So I have to line a whole bunch of them up to build this line segment. And in order to get it to build, you've got to have an infinite number of them. The reason there's 3 on there is because I took 3 of those infinite points and made them special and gave them their own names. Okay. So there's still an infinite number I can choose from. Okay, so quick question. Let's suppose this was 4 feet and this was 5 feet. How long would that little guy be?
1 foot.
Is that a fairly easy concept?
Yeah.
Yes. Okay, good. And then I could change that and say, okay, well, what if this was 7 and this is 2? How long is this? 9. Okay. Am I being oversimplified here?
Yeah.
Okay. The 2 little guys have to add up to be the big guy. Yes.
Yeah.
Okay. Good. So we're going to carry that concept on into some of these further calculations. All right. So we're good with betweenness. Again, remember, it doesn't have to be in the middle. That's something later. So as far as notation goes, we have 2 different ways of, well, we have 2 different symbols, let's say. The one on the left, we've seen already. That is the segment connecting A and B. That's a physical object. Okay, you saw one in the previous slide. Without a symbol over those 2 points, that represents the distance from A to B, which we'll be calculating later. Okay, that's not the points A and B. That's the length of the segment from A to B. And hopefully you already realize this. You can measure the length of a segment. You can't measure the length of a line because it goes on forever.
I mean, I guess you could. Infinite foot. Or like infinite feet. Infinite feet.
But, okay. Sure. All right, cool. Okay, so here's the type of problem. We've got a segment AB. Sorry, I lied. We have a segment AC, and B is between A and C. And then we have some algebraic values for that. So what I'd like you to do first, before I get into the actual calculations, is in your notes, draw this situation. You've got a segment AC with B being between A and C. Draw that first, and then we'll move on from there. And again, it doesn't matter where you put B as long as it's between A and C.
That's funny. There's a B in here. You said like.
Speaking of bees, the bees were out in force this morning, weren't they?
Yeah, they were. My friend Hallie wanted them like this year.
I got one stuck in my bow.
Dude, I got one stuck in my hair.
I saw you freaking out.
There was one of my hair.
I was trying to help with the card things, and I looked, and everybody's got a blue card except you. I'm like, what is she doing? Why is she standing there with a white card? Then I realized you were being swarmed by a bee.
Yeah.
It's not a fun time. No, it was a live bee.
There were
And
so
it
many.
just stuck. And all of a sudden everyone's freaking out. I was like, what? What? And they're like, because
Oh, if it's in your hair, you don't have to worry about it, because it's not going to sting your hair.
yeah, but then it can stay in my hair.
It can stay in your head.
Yeah.
My friend had it.
You'd rather have it-
You'd
You'd rather have it in your hair than on your scalp or on your arm or down your shirt.
What if it's just
Okay, but like the fact of having a song, it was like if I was like,
Yes, I agree. Okay,
Ow.
sorry to distract everybody. Okay, let's go back to the problem now. On your picture, label the distance AB as 3x. Label the distance from A to C as 5x minus 4. And label the distance from B to C as 14.
What, can you say that again?
It's all up there. Look to your right, Jack.
Oh, I keep
Good as I am.
This makes no sense.
keep forgetting it's
Didn't know if you noticed that big 55-inch TV to your right.
Yeah.
It's the big white thing.
Yeah, I keep forgetting
Is this
it's
the only classroom in the school like this?
Yes, so yes.
There's a VR lab downstairs that's kind of like this, but not nearly
It's
as
different.
cool.
It's like, it's open concept.
Yeah.
It's perfect.
Can't wait to play.
What's that?
It's perfect. That room's perfect. This is kind of big, large, tiny.
Which is kind of funny because you've got VR helmets that you're going to put on anyway, so why do you need big TVs?
They just like, people on top, I can't see what it doesn't.
Yeah, we have like monitors, not TVs or no, we're
Okay, we good?
No, okay.
Now, here's the fun part. Set up an equation involving that picture.
Yeah. Wait, this is easy. Wait a second. I did it. I got my equation.
Thanks for sharing, Jack. No. And then when you get your equation set up, solve for x and see what you get.
I'm gonna erase my stuff so I can read it.
Good.
I know I did this stuff.
A lot of people got it. Hope they're right.
Yeah.
See what Haley gets.
Yeah, I just erased it because I saw that early. I didn't want to. Wait, what did you get? Yeah, she did. She got it right. Yes. You're wrong.
Uh-oh, we'll figure out who's right and who's wrong.
We're right.
Check your pictures out. Make sure your pictures are set up correctly. Start there.
We had to say. Yeah. Wait, guys, we can check. I did 5x. Okay, I got 0. Oh, I see I did wrong. I shouldn't have that x there.
Okay, so let's take a look at this. So I set it up that way. B is between A and C. I have no idea how close B is to A or to C, so I just winged it. Put in the information that I know. And based on what we talked about in the previous slide, the two little guys add up to be the big guy, you would get that equation, right? AB plus BC equals AC.
Wait. Oh, wait.
Okay. So for those of you that are visual learners, the two little guys added together have to be equal to the big guy. 3x plus 14 equals 5x minus 4, so x equals 9. And you'll notice that in the problem it says not only to find the value of x, but also find the value of AB. And in fact, you can find the value of AC also, but it doesn't ask you to do that. When you're doing these types of problems, don't assume that you just stop at x. There's usually going to be more information that you need to solve for. Okay? Now, one thing we don't know is that 3x is not equal to, or one thing we do know is that 3x might not be equal to 14. Common mistake with these problems is you automatically assume that b is in the middle. It's not. That's not now. That comes later. Okay, questions on this? We're good? Excellent. Solve that one.
Here's a German line too.
I would.
Oh no. Oh, we're doing it now.
Wait, is ST?
Oh, it's definitely that.
So ST somewhere.
Oh, wait.
Oh my god.
Is it so back to you?
S to T is 7.
I'm not being critical. I'm always looking for something new to drink. I stopped drinking soda. I was a big soda junkie. I stopped drinking soda in March. So I'm trying to find, like I just started drinking coffee. And I'm not saying I really like it, but I'm always looking for something new. But this I can't drink. At all. Well, and it's a catch-22 because I was drinking diet. But it's got all the wicked chemicals in it, so, but I can't handle all the sugar. Like that sugar would kill me.
Yes.
I just need the energy because when I wake up, I'm absolutely dead. If I don't have any caffeine in the morning, I don't literally fall asleep.
So you're totally
You got an answer.
You can always just grab a coffee.
Find the value of x and s. Plug and chug. You know what st is, right? 7x, I think your value of x.
Oh, I thought it was 13. I'm so stupid. When did it 48? Yeah. Okay. And then you divide. I just write it 13. Why don't you write it 6th grade? Oh, okay. That's what I did wrong. Yeah.
No, I know.
But my house is bigger than yours.
I value my sleep, but I'm still always awake. I'm glad I did that.
You got time for that one? Thank you very much. Okay, we're all good? Okay, so again, solving for x. Walking around the room, it seems that everybody got 4 for x. But again, notice there's 2 questions in this problem. What is x and what is st? How do you find st?
Plug and chug.
Plug and chug. Okay. Plug and chug. Take the value of 4 and put it into the equation. Okay, so we want to talk about notation more than anything, and also a new phrase, or a new word I should say. Do you know what the word congruent means?
No.
Yes.
Wait, con is
So what's it
together.
mean? Same. Okay. So we're going to make a distinction in this class between the term congruent and the term equals. For our purposes, we're going to use equal signs if we're talking about numbers. Okay, 7 equals 7. If we're talking about physical objects being the same, and for our purposes it's going to be same shape, same size, we're going to use this word congruent. Okay. So I have these 2 segments, CD and AB, and I want to denote in the picture that they're congruent, so I put what's called tick marks on them. Those are the 2 little dashes on there. If you look at a big complicated picture, segments with the same markings on them will be congruent. So if I had other segments I wanted to show congruent, I would maybe use 1 tick mark, or draw a smiley face, or whatever. Smiley faces match smiley faces. 2 tick marks match 2 tick marks. Okay. So the top one, AB is equal to CD. You'll recall from a previous slide that AB is the length of the segment AB. So this is saying 8 inches is equal to 8 inches. 8 is equal to 8. Here we're talking about using that new symbol, by the way, which is congruent. It's an equal sign with a tilde over it, for those of you that are taking Spanish. That means same shape, same size. It seems like I'm getting overly picky about it, but we want to stay more in the congruent world because that has a better application for what we're doing. If you're solving algebraic equations, that's a different story. Those are equals. But when we're talking about objects being the same shape and size, we're going to use the congruency symbol. Have you seen that before?
Yeah.
Good. Okay. And I talked about tick marks already. Ways to show that things are congruent in a picture is using tick marks. So we'll get more practice with that as we go on. Are we good?
No.
No. Not yet. Oh, it is okay? Okay, hold on. I'll come back. Okay, so we're good. Questions? I'll unlock day 2 for you. I'll leave that up for those of you that need to get caught up.
Can I go next?
I don't know, can you?
Man?
Yes.
I'm so careful about saying, hey, I did